My name is Kay Bjornen. I am from the OSU Library, and my job is basically to help teach and introduce people, help people as they need it with tools and ways to better manage their research data and help with research processes. So one of the things that we have been quite involved in is trying to introduce this R and Python mostly through the data carpentries and software workshops here on campus. And our objective for today is we are really here to try and introduce this on a level for people that either haven't felt that they had the time to devote to taking a 2-day-long workshop, or perhaps they hadn't really considered that there was a better and faster and easier way to do some of these things with a tool like R. And so unlike carpentries, which is taught using live coding, we are not going to be doing live coding. We are just going to be doing this as a demonstration. So you all can sit back and as you're interested, you can download a few things or jump on and look at things, but there's no pressure. So this series will be spread out over the month of October, and the next 3 weeks, we'll have Clark Iakavakis, who is my colleague here at the library, will be teaching cleaning messy data with R, and then Phil will teach data analysis on the 21st of October, and then we'll wrap it up with data visualization with R on October 28th. And if this gives you a taste for what we do and you're interested in more, all of the workshops that we offer are available at the URL there on the library webpage. I'll also point out that the slides are available for download at the URL there. And Phil, if you might be able to access that and drop it into the chat for folks. But anyway, that has more than just the slides that we'll be using today, because I took advantage of a very large number of slides from Clark's library. He has taught R for librarians fairly often, and so there's some more detailed information about getting started with R in the slides that are hidden that you won't see today. So we're going to start here with this diagram, which I think is a fairly realistic depiction of how most of us do our data process. You usually start out with the data that you've either collected or that, maybe it's secondary data from another source. And then you have to go through a rather messy and time-consuming process of back and forth, trying to get it cleaned up, turned into the format that you need, evaluate it that way, go back and start over when that doesn't work. So as the picture here depicts, it's not exactly a linear process. And then once you do eventually get over here to the right-hand side where things are finally the way you're happy with them, and after you've done your analysis and visualization with that data set, then it's very likely you're going to need to repeat that process with another data set and maybe a very similar data set. And it's not quite as difficult, but it may still be a little bit messy. And so using conventional tools like Excel, most of us have experienced some of the drawbacks. So this is a more idealized process, and hopefully using R will allow your workflows to look a little more like this. And our workshops, today we're going to start right here and we're going to talk about importing data and just really kind of give you a peek at how the tidying process goes. And then next week, Clark will talk about tidying and mostly about transforming your data to turn it into that format that's going to work for what your analysis needs to be. And then Phil will do the third week of modeling and analyzing. The last week will take care of this part with mostly visualizing, but of course a lot of that is about communicating. And this diagram, as well as quite a bit of the rest of our workshop, slides and information, has been taken from an excellent resource called R for Data Science. And the URL that you see there will take you directly to the PDF downloadable for free version of R for Data Science. And if you're not familiar with it, I highly recommend it. It is just an outstanding resource. But before we get to R, we are going to start with spreadsheets. And why are we going to do that? Well, it's because most data collection begins with a spreadsheet. And I'm willing to bet there's not anybody who's joined us today who doesn't spend at least some portion of their data collection time in a spreadsheet. But I can tell you from my own experience that if you have never thought about making your spreadsheets machine readable from the very beginning, that you are probably making work for yourself, because our tendency is to use a spreadsheet more like a journal or a lab notebook. And by that, I mean, I know that many of my spreadsheets have columns that are highlighted, or notes, comments dropped in, or I'll drop in some additional information in a cell that's to the side of the table of data that I really need. And the truth is that by doing that, we make our spreadsheets awkward for uploading into software for analysis. So it's a very good idea to start right from the beginning with a spreadsheet, thinking about this data is going to go straight into my software, and so I'm going to make it machine readable. So one way to get around the fact that you really need all of this additional information is to create a text file or a README file to collect all of that information that you might be tempted to drop into the spreadsheet, but it's going to work better if it's in that text file. So this may be where you keep your additional notes. You may define variables there. You may talk about units, derivations that you're going to use the data for. And a particularly important one is, how is the spreadsheet going to deal with null values? Another thing you should think about when you're setting up a spreadsheet to be uploaded into a software program is about naming the fields. So if you're not careful with your column naming, then you're going to wind up with things that you have to fix later. So start right from the beginning by naming your fields with shortish, as short as you can make them and still make them meaningful names. No spaces, leave out special characters. Most of them are not readable by software programs. And here's where we get to the essential rules for tidy data. There are only 3 of them. You need to have all your variables in columns. You should have all your observations in rows, and you should have only 1 data point per cell. And so we have a diagram here again taken from R for Data Science that kind of sums it up very nicely. And that's what your data should look like. So let's start with an example. So this is really starting from the very beginning. And this is a project that's been undertaken by the OSU library that I think is a particularly cool one, and I'm happy to draw your attention to it. There were 2 leather-bound volumes of weather data collected by the Agricultural Research Station here at Stillwater starting in 1893, and the data goes through 1940. The picture you see here is the PDF, or the photo of what the data looked like before it was transcribed. And so if we look at this carefully, you see up here at the top, it's got the date, the month and the year. It's got basically metadata. What do we need to know about this data? And where it was captured from: Stillwater, Payne County. It talks about the time zone, latitude and longitude. Then on the right-hand side, you can see that there's summarized data. So temperature means and maximum, minimum, precipitation, same. And then if you go all the way down to the bottom, you see that there are some notes penciled in here about just, extreme low temperatures damaging to wheat, etc. Again, useful information, but not useful in the context of this table, because the main data is shown here in these columns. So we have, and unfortunately our picture kind of cut off the date, which is the far left column. But you see we have maximum, minimum temperature ranges and for each date, and then precipitation. But our headers are doubled up. And then over here, we have some text data about just winds and, general descriptions of the data. And so I had a link in here, but I don't think it's going to work for me. Let's see if it does. Yep, nope, doesn't do that. So get over here and I will show you the data from the spreadsheet. And this is laboriously transcribed by our metadata librarian here in the library, and I assume her assistants who are students. And you can see that they have captured the metadata up here. Well, actually, I guess this is the notes, the summary data. And then in the columns, or the header here, we have the date, we've got the temperature, again in a double header, and so on. And then we scroll down and we see that here's where the temperature data is recorded. It gets more interesting when we start looking at the precipitation data. We take note of the AM, PM, and then here at the time of ending, we have both a 7 p.m., so it's numerical, but it's also has some abbreviations that I assume mean daylight and dawn. And then we have over here, we have, on the days that we captured precipitation information, we have numerical data, but then we have blanks. And here we have, text where T undoubtedly stands for trace, and we have the amounts on the days that we recorded data. And then all the way down here at the bottom, we have summarized the quantities, undoubtedly because they were manually calculating these averages, the means. And then we know who recorded the data and where. Okay, so now from there, let's go to our next slide here and talk about how we turn that into tidy data. And so again, what we're going to do is we are going to use a text file or a README file. I wrote this one up in Notepad and captured all that metadata. And that file will be saved in a folder with the monthly weather data in the spreadsheet once that's cleaned up. And let's see what that looks like. So this is our tidied data, mostly tidied data. It actually has some issues. But you can see now we are going to abide by our 3 tidy data rules in general. So we have columns with variables. We have our observations in rows. The one thing that we haven't got quite straightened out is some of this has, the columns may have more than one type of data in them. The cells generally only have one type, but you see that when Excel converted our times, it converted it to decimals. And so that's a little bit messy. And of course, if you've dealt with Excel very much, you know it's also something that you have to be extremely careful with, because it's also a common problem dealing with time and dates. The other thing I'll draw your attention to is the column headers now are turned into machine readable labels, and we've kind of mashed in the information so that now we know, you'll recall that temperature was written across the top, but now the field name has, the temperature maximum in degrees F, and so on, all in a machine readable format. Okay, so now the problem with that is that, remember, this is 40 plus years of data, and it has to be done month by month. And if you are cutting and pasting the metadata into a text file, that opens it up to errors. Cutting and pasting can definitely be an error-prone process. It is time-consuming, laborious in the extreme. And if you have multiple files that really need to be consistent, it's easy to not reproduce the exact same format in the exact same information. So let's find a better way. And at this point is where I will acknowledge that every time that we get into this, there has to be a better way dilemma. We have to acknowledge that learning new tools takes time. And so you have to balance the benefits of learning the tool and saving yourself time using the tool with the time it takes you to learn it. So we are not here to minimize that issue. It's certainly something, but we'd like to think that we can make it a little easier for you by we're going to share a number of different ways to learn this and learn it in bite-sized pieces. So let's start with what is R. So this may be extremely basic. Most of you have probably been exposed to it. But R is more of a language than a statistical program. It began as a statistics program. That was kind of its origin, but it has expanded well beyond that. And so now the originators, started it to do data analysis and graphics. It can do much, much more. And so over the course of this month, what we're going to talk about is really the parts about data cleaning and reshaping, data visualization, and statistics and modeling. But when I was introduced to R, I actually was introduced to it through data mining. And so, there's a lot of capability that if you are interested, you can dive in deep. And so the advantages to R, why R? Well, for one thing, because of its origins and that it was built specifically for this purpose, it can do very complex data manipulations. Automation reads any kind of data. And the second to last bullet point here on the left, larger data sets. This is one of the huge advantages over Excel, because Excel has limitations to the number of lines it can read in and accept into a single spreadsheet. And I think there was some well-publicized early in the COVID era, there was some well-publicized boo-boos when I think it was in the UK, they were using an old version and didn't realize that it was cutting off their data in the government data collection process. So that is significant. And then over here on the right-hand side, the second bullet down also mentions a significant advantage. It is free and open source. So if you are a user of SPSS or Stata or another statistical program, this is a huge advantage. To get to R, you go to this URL and you download it because it is free. You can do that anytime. And it is set up so that you select your country and you also select your operating system, and then you download it to your device. And already mentioned, it's free and open source, but one of the reasons why that's a huge advantage is if you do get deeply involved in it, you're able to contribute. You can get to the source code, you can tweak it, you can create your own packages, and just commit to using R at any level that you choose. One of the advantages of R is that it has been adopted by so many different fields and companies, and again, because of the open source aspect, they've been able to create the packages that they need for their applications. And in fact, that's one of the reasons why this particular workshop is being held, is to show you exactly how we can use that for agriculture. Getting help. Another big advantage to R is if you have used any software in the modern era, you probably are already familiar with the fact that, most questions, error messages, and so on, you can Google and you can come up with an answer. But if you need a little more sophistication, there's a couple of options. One of them is Stack Overflow, which is a web-based community where it's expressly for sharing information about different software platforms. Or there are a lot of listservs and emails out there for, again, different communities inside of R and sharing information. But there are a couple of drawbacks to R. One of them is that objects must be stored in physical memory. And what that means is that, again, if you are using an extremely large data set, you need to be aware of how much data you have available on your device. The other thing is there is no graphical user interface. And so if you are not comfortable using command line, R itself can be a little limiting. But we have a very slick answer for that. And that is a complementary tool called RStudio. RStudio is an environment, and it has a very nice interface that allows you to work with R. And so you can do everything on your screen, import your data, write your scripts, install packages, etc. And we will look at that here in just a minute. One of the huge advantages to R is what call the power of packages. R is extremely flexible because packages have been developed that bundle together functions that accomplish similar, that work together. And so they share design philosophy, grammar, and data structures. And the Tidyverse is probably the biggest and most used as far as packages go. So let's take a quick look here at the information about Tidyverse. As you see, it's very easy to get into. This is in RStudio, and it tells you about each of these packages. We, in this workshop, will look at Tidyverse, ggplot, dplyr, and we'll look at tidyr here in just a minute. You can see that there are others listed on this page, but these are the ones we're going to take a look at. So let's real quickly just go here. You can see that the web page for the tidyr package, again, up here at the top, it talks about, what you're going to do to create your tidy data. A vignette gives you some case studies or examples. It tells you how to install it. And the one thing I really wanted to draw your attention to is cheat sheets. This is another thing that you can find in RStudio that is so helpful, because cheat sheets, especially in the learning stages, you spend a tremendous amount of your time saying, okay, wait a minute, which order does this go in, and what was the exact name of that function, and so on and so forth. So a cheat sheet lets you look at it and quickly do it more quickly than you'll be able to do by dredging it up in your brain. And so that's the example for the tidyr. So up to this point, what we've talked about is tidying data out of a spreadsheet where you've got, stuff added in that shouldn't be there to make it machine readable. But the truth is, there are a lot of ways that you may need to tidy your data. And so this little adaptation of the Leo Tolstoy quote is one that is commonly used from Hadley Wickham, who is one of the authors of R for Data Science. And so with that, let's go ahead and get out of our slides and get into RStudio. Okay, so this is what RStudio looks like. And RStudio is built in panes. And so up here we have what is called the console. And the console is where you can enter, it basically can act like a calculator. You can do, you can print something to the screen if you want to. And one of the things you may or may not have noticed is, and it provides you an output. When I was entering that, so let's do it again. Let's do P or I. Okay. One of the advantages to RStudio is it provides you with some, prompts you. And so when I did this workshop yesterday, I forgot that print should be lowercase, and I typed it in, and it said, it gave me these options, and I said, oh yeah, what I want is lowercase. So you just hit that, and it automatically enters it. But if you are wanting to create a script, so what you enter in the console is temporary. It will not be saved. When you get out of this, it will be lost. So what you usually want is, you may do some playing around in the console, try things, make your errors there. But when you want to save something, you're going to want to do it in the script, because you can get up here and you'll be able to save as and put this in a file and bring it up later. And that's the real value of it. So, okay, this usually, if you have something that you've done, you can pull it up in recent projects. I'm working on the library computer where it may be, I may have some challenges, we'll see. But anyway, so let's go over here to global environment, or to the environment screen. And when we start creating things, this is where the data sets that you load and the objects you create will show up. We don't have any of that yet, but the other advantage is you can get in here and we can look at the packages. And so let's look at tidyr, because that's one that we're going to be using. And so you can see that this tells you what the functions and some of the, okay, I thought there was a, all right. Yeah, okay. So there's data sets loaded in here, and I wanted to draw that to your attention because we are going to be using these data sets here in a minute, and because they're already part of the package, we don't have to load them in. And then finally, here's your history. If you can go back and look and see what you did, and tutorials if you need to learn how to do something. There's some tutorials that are right at hand. Then our bottom screen here, this acts like a directory, and you can see your directory structure. When we create plots, it'll show up there. And this is where you can tell which packages have been loaded. The check marks will tell you which ones are available. There's also a help menu. Again, for quicks, you can do a search for any function that you're wanting to find information about. Okay, with that, I am going to see if I can open a file that I opened earlier. Wait, there it is. Okay, recent files, sure enough. All right, we're going to open this one because I mentioned that the tidy data, Wickham's quote about every messy data set is messy in its own way. So let's look at each of these. These tables all represent the same data set, okay? But it's easy to see that they look different. And the top one here is the only one that qualifies as tidy. So in this one, first of all, it tells us it's a tibble 6x4. Well, that information will be more meaningful to you next week after Clark talks a little bit about that. But a tibble is a table or data frame, a special type that is used in the Tidyverse. Perhaps more valuable is it tells us it has 6 rows and 4 columns. Okay, so it tells you the size. And so when we look at it, we have country, that is our heading. And you can see that there are countries listed, and there's they're double, two entries of each, because the data is for 2 different years. And then it shows our cases of something and the population, all right? It also tells you the type of, the data type. That's what the information in the brackets there is. So if we go to table 2, now we see the tibble is 12x4. And the reason for that is because we now have, under Afghanistan, we have 4 entries. It's still 2 years of data, but now we have the cases and population are listed in a column. And that's not actually a value, it's a heading, okay? So this violates the tidy data rule. It's no longer got our data, our observations in rows. And then table 3, similar type thing, except here, now we have it's set up to calculate a rate. And then the last 2 are separated out so that the tibbles have the 2 years worth of data, but we're showing cases and populations separate. The reason for doing that, as people who have worked with data, there's many good reasons to set up your data in different formats. And depending on what you're doing with your data, there are other formats that may make sense. But for us, what we want for use in R is for all of our data to be tidy. So what we're going to do now is we are going to take a look at how we can turn these last two tables into tidy data by using some of the commands that are available to us. And before I start that, I am going to clear my console. Oops, at least I think I am. Okay, now I have a clear console. And then what we're going to do is we're going to take advantage of, I'm also going to do a time check here. Okay, we're good. Okay, the other thing we're going to do is look over here, and so under functions, we have something called pivot longer. And this is a function that's going to allow us to combine our two, we're going to pivot the columns here that have cases and population that are actually labels. We're going to turn those into labels, and then we're going to pivot the count information into values under those labels. And the other thing that we are going to do is we are going to start by, actually I should, I would normally need to check my working directory and so on to be sure I could access my data. But in this case, because the data is in the package, I don't need to do that. So we're going to create an object called tidy4a, and then we're going to use what's called an assignment arrow, except that, yeah, here we go, to tell R what that value of that object is. And as you see, I'm being prompted because it recognizes that the data has already been loaded. And now I'm going to use what's called a pipe. And that's going to say, okay, take that data and send it to this function, which is pivot longer, and it prompts me for that. And now I'm going to combine the dates and then tell it that those need to now have names to year and values to cases. And if I didn't make any typos when I hit that, okay, I have to change my environment because I'm still looking at the package. Let's go back to the global environment. And sure enough, it did create that object. And, you know, I can click on that and you look at it and say, oh yeah, that's, you know, these are the correct variables. Okay, I'm going to do the exact same thing with the other table now. Trying to do it as quickly as I can without making any errors. And now we go, same thing, names to, we want the names to go under year. And the values, in this case, will go to population. Except that I forgot my comma. Okay, now should have created a second object, and that should also, we've now created this variable, and it gives us a flavor for what it looks like. Okay, now what we have to do is we have to do the last piece of this, which is we have to join this, these two tables into one to make it look like the other table. So we use a function called left join, and we tell it which objects we are joining. And if all goes well, then, okay. So there is our joined table. And it shows us what it looks like. And if we roll up here and look at table 1, we accomplished what we were trying to accomplish. Okay, so again, this is just a taste of what can be accomplished with the Tidyr package. But what I'd like to do now is let's go back to our weather data. And one thing that we can do at this point is we can import that spreadsheet that we cleaned up, and that data should now be usable in R. So let's check and see if we're right. First, I'm going to, let's see. I would normally have to set my working directory, but again, I did this earlier, so I don't have to. And so instead, what I'm going to do is I'm going to create an object, and I'm going to use my assignment arrow with the read XLS command, because that is a package that is available to us. And we have to tell it where to find the data. All right. And it did create another object. And so that means that it read our data in, and we have 31 observations of 14 variables, which is wonderful. That's what we were looking for. So now it, because we typed it in the script window, it did not show us any output. So let's take a look. And we can either look at it here, down here in the console. The other thing that we can do is use a function called view and look at it in a separate window, which can sometimes be rather convenient, because you'll notice in the script, in the console, you only get to see the first few rows. So by doing here, we can see the full spread of the data. And yeah, I just realized that this is really tiny script. My apologies for that. It's kind of late to be realizing that. But anyway, hopefully you can see it well enough to tell that we accomplished what we were trying to accomplish here. All right, I'm going to go back here, and I'm going to do one more thing as a way of just kind of introducing our next our topic later in the month. And we're going to create an object called plot1, and we're going to use ggplot and just do a very quick and dirty plot of this data. So we tell it what data we're using. Now we're going to tell it what variables we're going to use to graph. And X we want to be date. Y we want to be just going to use the maximum temperature. Whoop. Try again. And that will create our object. Except that apparently I have no comma here. Okay, now we have our new object and it shows up here. So to plot it, we're going to take the plot, the name of the object, plot1. We're going to tell it to create a line graph. And enter. And here we get this lovely, lovely graph. But if you're doing a quick look at data, sometimes that's all you need. And with that, I am going to stop with RStudio and go back to my slides. Did I close them? Looks like I did. Okay, got one more slide here, which is basically just resources. So again, if I've intrigued you enough to make you want to go look at some other resources and get started, here are a few. The carpentries, again, we have a very active carpentries community here at OSU. We teach workshops, normally about 3 a semester. This semester, it's only going to be 2. We taught a data carpentries workshop with R in September, and we will be teaching another data carpentries with R, but it's a genomics workshop in November. So if that interests you, by all means, check into that. The information will be available on the osucarpentry.github.io page when it's up there. It's not there yet. And we have a page here with just general information about OSU carpentries. If you're want to learn more about carpentries, it's at their web page. And then I can't emphasize enough how valuable RStudio is. This URL will take you to all kinds of information that's good if you're learning RStudio, learning R and using RStudio. I've already mentioned R for data science many times, so there it is again. And then the last thing here is something called Swirl Stats. And that is a self-paced tutorial. It'll walk you through every phase of learning R, and I think it's excellent.